All right, so what we're doing is, give me a second, I'm posting this. What we're doing today is we continue live testing, okay? So we continue live testing the harness and improving it. We're doing this by working on the free energy principle workspace. And last time I did a bit of these, right? So we've got the center topic, and I'm gonna leave these things for later. As I said, I'll one of the things that I've seen happen a lot is that these guys seem to be. It seems to be like usually like from a workspace perspective, these are always the best choices. Um, which makes sense. These are more tangent topics, although epistemic foraging is actually an interesting one that I stumbled upon today as well. But I mean, we'll focus on these. Okay, we'll just go straight to play. We'll go straight to play. Um, and we'll explode with AI. That's my favorite mode. It's not going to be perfect. Okay, it's not going to be perfect. We're building these as we're working through. Okay. And again, remember the concept here is we are exploring, right? So this is not something that when we do exploring mode is like we're hunting for we're foraging for uncertainty to actually minimize. Give me a second. So I'll do probably just sort of 20 minutes. Okay. Let me put some music in the background. We've got start block. I've changed a few things here from the last feedback from the last session. So now we kind of have, okay, so we've got open the horizon, what do you already mean by prediction, surprise, and a system that stays alive, and where those ideas feel fuzzy for the free energy principle. Um, this builds on top of the session I had before, I guess. So what we have is we were talking about prediction in the sense that, and let me see. Yeah, cool. Okay, perfect. Seems to be working. So we're talking about prediction in the sense of we've got our model. So the core principle here is we've got our model, and um, and we are essentially the model is trying to predict. The model is trying to understand, I guess. I guess it's not prediction, but the model is trying to understand what it's seeing. It's trying to explain what it's seeing, right? So I'm not so sure if prediction is the right word here. If I understand this well, the model is trying to understand what it's seeing, what it's perceiving. And surprise is basically when it cannot find an explanation where where the perceived data of the environment doesn't match our internal model. So I guess that's what I guess prediction is the wrong word. That's what I was trying to say. But the surprise is a technical term, as far as I know. It's still the right word. Interesting. The system carries expectations about what sensory data should look like if it's model of the world and not staying viable. It's roughly right. Surprise is when the data don't match those expectations. Not no explanation exists. but this doesn't fit well enough yet. Tighten one piece for this chapter. In your own words, what does stays alive and beyond matches the data? Preferred states, not just any consistent story. Reply with that, and then we'll pressure test it on a tiny example in the next chapters. Stays alive. Let's check this out. I don't know. What does stays alive in the free energy principle context mean? Does it mean that it stays alive as in like it's an always on model, right? Mm. Oh, persisting as a living system. That's what it means. Okay. Then we can go back here. So staying alive means that the goal, our inner goal is to persist as a system. It's basically not to die. Stay within the range of states you can actually occupy, not overheat, nor not starve, nor dissolve. This is interesting. Not overheat. This is interesting. You know what would be cool? It'd be cool to kind of like bookmark, be able to bookmark stuff. You know what I mean? Well, in a way, it is like, can we like not overheat? So can we do these? Well, so what we can do is these. I can create a so not overheat, not starve, nor dissolve, not die. States. Why does this have a DAG automatically? Let me. This might be a bug actually. This might be a bug actually. Okay, but we keep it here. That's good. Surprising for that system. One more turn on this horizon. Name one everyday case, body temperature, hunger, or a simple thermostat, and say what would count as surprising for that system versus merely unwanted. Okay, let's think about this. So, I think as a surprise, it would be like, for example, that you're called in a room and you go and turn on the heater, and your mental model expects that after a while you'll feel warmer because you've just turned on the heater, right? But if the room doesn't get warmer, then that is a mismatch, a surprise. It's basically, it adds uncertainty because you did not expect that, and now you gotta go and figure it out, I guess. I need a better interface to submit the stuff. I think that's not obvious at all. I know how to do this, but I feel it's maybe even not too intuitive. I'd like this to be somehow more natural. That you're like, anyway. Sorry, prediction is warmth, should rise after I act. Checkpoint, you can explain prediction as expected sensation, surprises, mismatch. Stay alive is solid markers done. heck is that? Crying babies. Anyway, to be honest, I don't know what's supposed to happen now. I kind of like forgot. Is it supposed to tell me something, or can I just load the next chapter? It feels like I can load this one. I'm not so sure. I should be able to load this one though. Loading chapter. Open the notebook and pick one concrete case, thermostat or simple organism. Write 3 short blocks. Priors, what the system expects about the world. Set points and sensory input, one concrete reading it gets now. Surprising prediction error, what would count as a big mismatch and not as just wrong. Keep it one scenario, a few sentences each based or point me out what you wrote. Let's do this. So I guess we'll do priors. It's basically, and as a note, you see what the harness is doing, right? The harness is prompting me to take certain actions, even though like I've talked about these. Now it's asking me to write it down on a notebook. This is to create the action of like typing something out, thinking something through, right? Even though you've already, I have it in my head. I'm tempted to just say I've done this. I don't want to, that's not the point. Just as a note for this. So priors would be set point or preferred branch. The system, like the scenario. It is winter, midwinter in northern Germany. And it's called outside. Priors, if the heating hasn't been on, the room at my house will be cold as well. Or why not as cold? Sensory. My body feels that it's cold and goes ahead and tries to turns the heating on. Sensory input expected to slowly rise temperature. Surprising prediction error. The room doesn't get warmer at all. Now these essentially this essentially kind of I guess I have to add to the priors that turning on the heater means that the room will heat up. I think that is part of the priors, right? This is part of the priors, and then sensory, my body feels at the call, it is called and goes ahead and turns the heating on. Sensory input expected to slowly rise temperature. The room doesn't get warmer at all. At all. This essentially means that now I have more uncertainty in the system, so I either have to change the model of the world and update my priors, which, to be honest, I think you do both, right? I think in this case you kind of do both, right? You like, or take action. Action would be directed into minimizing the uncertainty, but in this case I'll also update my priors, because now I did stumble with a situation where turning on the heater did not result in heating up the room, which likely means there are other factors, and hence my prior should increase temperature and not must increase temperature. And then I'll take some actions and go figure out if the window is open, the heating is broken. But I think that basically pretty much solves it. Yeah. Your scenario is workable. Homing with a called heater lever. Let's sharpen it without rewriting it for you. Tighten 3 labels only. Priors. Preferred expected room state before you act, not heater will heat. What temperature band does the system expect to occupy? Preferred expected room state before you act. Sensor input 1 reading now. Separate from the decision to switch the heater. Prediction error. Split sensation from action and from later belief update. Repaste just those 3 lines. We'll check whether room stays called. Is error relative to the prior. Not a full active inference story yet. Stay on this chapter. Okay, so let's do these. Let's basically say priors. Let's refine these. I guess I mixed up. So priors would really be the state before acting. Priors, the room is called. Sensory, my skin feels it. Prediction error. Prediction error is strictly speaking, my skin still feels it. Cold. I guess that's what we can do. Just basically focus on these, probably just to prior, sensory, and prediction error. A prior is what the system is built to expect or prefer for the room. So the room is called. Oh, so the room should be warm. I guess that's what it is. The room should be warm. Like we expect rooms to be warm. I guess that's a prior. We expect that is why you have a sensory. That's what drives you to take action. I guess prior says the room should be warm. So that's the first mismatch in the scenario. The room should be warm. That's probably what it is. The room should be warm. My skin feels it. My skin still feels it cold after acting, right? I guess that's what it is. Yeah, cool. Should be warm is a real prior. And cold skin against that is prediction error. Good. Exactly. Yeah. Should be warm. So it has so my action hasn't fixed my prior. Yeah. Drop still sensory. Name one concrete signal now. Skin reads cold. Skin feels it. Yeah, skin reads cold. unless you state when before any drop steal, unless you state when before any heater action is fine for this chapter. Oh, that's before the action. All right, okay, that's before the action. So essentially, that's the idea here is the priors. The room should be warm. My skin says otherwise. Prediction error. Yeah. The room is cold. I guess that's a prediction error, right? Should be warm as per prior. Okay, so this is before the when we're talking about this in a prior sensory and prediction error, this is before the action. This is what triggers the yeah. Prior preferred warm room sensor skin skull that called reading against the warm expectation. As mismatch. That's interesting. Is the prediction error phrased as a mismatch? No, it should be the room is called. That's the error. Optional. The prediction error is that the room is called. I guess that's how it's phrasing it, right? It's the mismatch. Cold skin versus prior should be warm. Okay, so basically it's just the phrasing of the prediction error is the room should be warm. I think so. I'm gonna wrap it up here, guys. Not the mismatch. The error line is the prior again. What you expect, what you get, how does to differ? One short phrase that names the gap, not either line alone. Okay, the room is colder than I expected it to be. Is that the right way to phrase it? I hope so. I guess I have to drop. I'll continue later. See you tomorrow.